So the second form sets 1 to 3 all took the same Trinity exam, which was one non-calculator and one calculator paper. Now what I've done here, I've hooked out from both papers what I consider to be the key questions. So these are mainly the numerical and algebraic questions, and I've combined them all into this one paper that I'm recommending that the second form do over the summer holidays, just to sort of consolidate their key skills and to build their confidence. So you'll see in the link below you can download the paper from online, or you can ask your child to go and find it in the shared area at school. So just follow the link below if you want to download the paper before completing it. Question 1. So write 0.23 as a fraction. Well, the 2 is in the tenths column, the 3 is in the hundredths column, so this is 23 100ths. Question 2, so another non-calculator question. So we've been asked to write 4/5 as a percentage. Now remember, percentage means out of 100, so we have to convert this fraction into equivalent fraction out of 100. So I think the easiest way to do this, sort of convert it into being something over 10 first of all by doubling the top and the bottom. So 4 out of 5 is the same as 8 out of 10. Now in order to convert this to being out of 100, we now have to multiply by 10. 8 times 10 is 80. So 4/5 is the same as 80 over 100, which is 80%. Question 3, again non-calculator. So the ring costs £60, we pay a deposit of £40, how much is the deposit? So we're being asked to work out 40% of £60. Now the way to do these is to always start off by working out what 10% would be. Now 10% is a tenth, so we need to work out what a tenth of 60 is. So we divide 60 by 10, which is £6. Now this only works for 10% because 10 tens is 100. You can't think that 12% you would divide by 12 or 20% you divide by 20. That's not how it works. So you must start off by working out what 10% is. So 10% of £60 is £6. Now this is really a building block to build upon. Okay, so that's what 10% is. So how much is 40% going to be? Well, we need 4 of these. We need 4 lots of 10% to get 40%. So we choose to multiply by 4. So 4 times the percentage, 4 times the amount, 6 times 4 is £24. So 40% of £60 is £24. Question 4, part A. So we're told that a breakfast cereal has 40% fruit and the rest of the cereal is oats. So it's 40% fruit and 60% oats, because obviously the two percentages have to add up to 100%. Now we need to simplify this ratio. So 40 to 60, divide both by 10, we get 4 to 6. And then halve both of these, we get the ratio 2 to 3. So in normal circumstances, that would be the ratio that we give. Fruit to oats is 2 to 3. However, on this specific occasion, they're insisting that when we do the ratio, the first number is a 1. So not a 2, it's got to be a 1. So we're going to have to halve the 2 to get 1. So we've got to halve the 3 to get 1.5. So our ratio in the form 1 to n is 1 to 1.5. Now part B is important. A different breakfast cereal is made using only fruit and bran. The ratio of the weight of fruit to the weight of bran is 1 to 3. So fruit to bran is 1 to 3. Now we're being asked for what fraction of the weight of this cereal is bran. Now be careful not to say thirds. Okay, the total number of parts is 4. 1 add 3 is 4. So if we were being asked for the fraction which is fruit, we would say 1 out of 4, which is a quarter, but we're being asked for the fraction of the weight of the cereal which is bran, so that's 3 bits out of 4, which is 3/4. Question 5, again non-calculator. Keith and Graham share some money in the ratio 4 to 3. So Keith to Graham is 4 to 3. Now you've got to read the words carefully. We've been told that Graham gets £57. Not that they're sharing £57 between them. Graham gets £57. So the £57 goes in Graham's column. So his 3 shares are worth £57. So how much is each share worth? Well, we need to do 57 divided by 3, which I've done down here as the bus shelter. 57 divided by 3. So 3's into 5 is 1 carry the 2, so that becomes 27, and 3's into 27 is 9. So 57 divided by 3 is 19. So we've now worked out that 1 share is £19. Now Keith has got 4 shares, so that's 4 lots of £19. I've done that little multiplication here, so Keith gets £76. So if the question asked us how much does Keith get, the answer would be £76. But the question is asking us how much do they share in total. So we've got to take Keith's £76, Graham's £57, add them together to get £133 in total. Question 6, again non-calculator, being asked to express £180 as a product of its prime factors. So we've got to break it down into its factors, and each of these factors are going to be prime numbers, and then a product means these have all got to be multiplied together, hence the time signs in our final answer. So we've got to break the 180 down into 2 factors, any 2 numbers which multiply together to give you 180. So I've gone 18 and 10, but you could have gone 90 and 2, or whatever you like. It doesn't matter, you're going to get the same answer at the end. So I've broken 180 down into 18 and 10, because 18 times 10 is 180. Now neither of these numbers are prime numbers, so we can carry on breaking them down. So I've broken the 18 down to 2 and 9. I could have done 3 and 6, but I've done 2 and 9. Now 2 is a prime number, so that we can't break that down any further, so that gets a circle around it. But we can carry on with the 9 and break that down into 3 times 3, both prime numbers, so they both get circles. Now this 10 can be broken down into 2 and a 5, both prime numbers, so they both get circles. So this is our workings over on the left. Now our final answer is going to be all of these circled numbers multiplied together. Now it's a nicety to put them in numerical order, so it's 2 times 2 times 3 times 3 times 5. But as I mentioned earlier on, you must include the multiplication signs or you would drop a mark. It is not a shopping list, it is a product. It is numbers being multiplied together. Question 7. So we're told that P equals 2E plus 3G. So that's 2 times whatever E is plus 3 times whatever G is. Now we're told that E equals 6.5 and G equals minus 2. So we've simply got to substitute these in. We've got to replace these letters with these numbers. So 2 times E is 2 times 6.5, which is 13. And then we add on to that 3 times G, which is 3 times minus 2, which is minus 6. So 13 added together with minus 6, or in other words, 13 minus 6 is 7. Question 8. So we're told we've got a shape here made up from a rectangle and a triangle, and we've got to work out the total area of this shape. So all we're going to have to do is work out the area of the rectangle, the area of the triangle, and add these 2 areas together. Now exam technique is really important in something like this. You might not be able to get all the marks, but just pick up the easy marks. Now there was 1 mark going for this just to work out the area of the rectangle. How do you work out an area of a rectangle? It's just base times height. So 15 times 9 gives us 135. So that's our first area. Now to work out the area of this triangle, we've got to first of all work out the length of the base and the height of the triangle. Now how do we work out the length of the base of the triangle? Well, we can see the base of the rectangle is 15, so the height of the rectangle must be 15, of which this bit is 7. So this bit here must be 15, take away 7, which is 8. And again, good exam technique, just label all of your findings onto your diagram. Again, the mark scheme was such that you picked up a mark if you labelled either the 8 or the 13 for your second mark. Now, and how do we work out the height of this triangle? Well, we can see the height all the way up as 22, of which this length here, this side of the rectangle, is 9. So this length from here to here is 22 take away 9, which is 13. So our triangle has got a base of 8 and a height of 13. Now remember, to work out the area of a triangle, it's not the same as an area of a rectangle, because the triangle takes up half the space. So you've got to remember to do half times 8 times 13. Half of 8 is 4, so that's 4 times 13, which I've done over here to be 52. So the area of our rectangle is 135, our triangle is 52. Add these together, which I've done here, and you get 187. Now, in normal circumstances, there would be a mark going for the units, which there wasn't on this occasion, because we only had 3 marks to play with. Remember, the units for an area is always something squared, and on this occasion it's centimetres squared. So the final answer is 187 centimetres squared. Question 9. Now, to multiply fractions, it's the easy one. It's just top times top and bottom times bottom. But whenever you've got mixed numbers, whether you're multiplying, dividing, adding or subtracting, you should start off by turning it into an improper fraction, a top-heavy fraction. So you've got to start off by turning 2.5 into a top-heavy fraction and 1 1/3 into a top-heavy fraction. Now we'll come back to the shortcut in a minute, but how do we do this? So think about 2.5. On this occasion we are dealing with halves. So how many halves make a whole? Well, it's 2. So we're going to get 2 halves making up the first whole, 2 halves making up the second whole. So this 2 here, 2 wholes, comprises 1, 2, 3, 4 halves, plus this extra half. So we've got 1, 2, 3, 4, 5 halves. So 2.5 is 5 halves. Now the quick way to do this is just 2 times 2 is 4, add on the 1 to get 5, so that's 5 over 2. So similarly with 1 1/3, we're now dealing with thirds. So a whole comprises 3/3 plus this extra third, so that's 4/3. Or doing it the quick way, 1 times 3 is 3, then add on the 1 to get the 4. So 2.5 is 5 over 2, 1 1/3 is 4 over 3. Now we have to multiply these together. So as I said, that's the easy one. It's just top times top, bottom times bottom. 5 4s are 20, 2 3s are 6. Now we've been asked to give our answer in its simplest form. Now both of these are even, so we can halve top and bottom, giving us 10 over 3. Now 3 is prime, so that can't get any simpler. But we now want to convert this back to being a mixed number. So how many wholes can we get out of this? Well, we're dealing in thirds, and 3/3 make a whole. So 6/3 would make 2 wholes, 9/3 would make 3 wholes. So we can get 3 wholes out of it, using up 9 bits, 1 bit left over. So our final answer is 3 1/3. Question 10, part A. So what is a to the power of 4 times a cubed? Now remember that a to the power of 4 just means a times a times a times a, and a cubed just means a times a times a. So altogether we've got a times a times a times a times a times a times a. 7 a's there, so that's a to the power of 7. Now the quick way to do these, it's one of the index laws. When you multiply, you add the powers. 4 add 3 equals 7. Now, what's going on here, when you've got a power inside the bracket and a power outside the bracket, this is an occasion when you do have to multiply the powers together. So that's 2 7s are 14, so that's b to the power of 14. Now for part C, I haven't gone into explaining why now, it takes a little while to explain it, but basically we just need the pupils to learn that anything to the power of 0 is 1. So if it's 3 to the power of 0, or 5 to the power of 0, or x to the power of 0, learn that the answer is 1. Now I know it's counterintuitive, you feel the answer should either be 3 or 0, but it isn't. anything to the power of 0 is 1. Question 11. Now you see that none of these have got an NC next to them now. From now on, all these questions were taken off the calculator paper, so you're welcome to use a calculator if it would help. So, nice gentle one to start that paper. From the number in the list above, write down 2 different numbers that add up to be an even number. Now, there are countless ways you could have done this, so this is just an example, but 5 at 15 is 20, that's even, so there's one example of 2 different numbers. Right, part 2, a multiple of 20. Now the multiples of 20 are the 20 times table, so 20, 40, 60, 80, 100 and so on. So in this list the only multiples of 20 are 60 or 100, so either of those would have done. Now part 3, a factor of 45. Now remember what the factors are. These are small whole numbers which when multiplied by other factors would give us 45. So 1 times 45 is 45, so 1 and 45 are factors of 45. 3 times 15 is 45, so 3 and 15 are also factors, and the final two factors are 5 and 9, because 5 nines are 45. So the factors of 45 are 1, 3, 5, 9, 15 and 45, and the only ones of those that are in the list are 5 or 15. So either of those would have done. Now for part 4, a cube number. A cube number is what you get when you multiply a whole number by itself and then by itself again. So 1 times 1 times 1 is a cube number, and that's 1. So 1 is a cube number. 2 times 2 times 2 is a cube number, and that's 8, and so on. If you were thinking about a shape, a cube, okay, if the sides, the width, the height and the depth are all 1, you'd have a cube with each of its sides being 1. The volume of the cube will be 1, and so on. If you have a cube which has got sides of 2, 2 and 2, that would be 8. So again, that's where the term cube comes from, because these could all be the sides of a cube, and this would be the volume of the cube. So in this list here, the only cube number we have is 125. That was the only answer you could give for part 4. Question 12. Now, for these better value for money questions, the skill is finding out the value for the same amounts of quantity. So we're properly comparing like with like. And what we're really trying to encourage the children to do is to get back to a unit quantity. So back to a single roll of toilet, for example, with this example here. So a single toilet roll. So if we got a pack of 9 rolls costing £4.23, how much would 1 roll cost? Well, we're going to have to take off £4.23 and divide it by 9, giving us 1 toilet roll here being £0.47 or 47 pence if you like. So that's something we can compare in a minute. Moving on to this pack of toilet rolls, that's £1.96 for 4. So how much would 1 roll cost here? Well, you take your £1.96 and divide it by 4 to get back to 1 roll, giving us a £0.49 or 49 pence. So now we can properly compare equal quantities, 1 roll to 1 roll. So 47p to 49p. So the 9 roll pack gives better value for money because that number is smaller. I mean, you don't have to make it 1 roll. As long as you're comparing like with like, that's fine. But I think it's a lot easier to do what's called the unitary method, to always go back to finding out the cost of 1 unit of the product. Question 13, part A. So P times P times P times P is P to the power of 4. Had it been P, add P, add P, add P, that would have been 4P. Now part B, expanding, this is when we get rid of the brackets and we do the claw. So we're going to do x multiplied by x and then move on to the second claw, x multiplied by plus 2. Now x times x is x squared, and then x times plus 2 is plus 2x. Now second part B, by the looks of it. So we've got a double claw here. Really what we've got here is a couple of what we got up here. So we're going to have 3 times y and then 3 times plus 2 and then 4 times x and 4 times minus 1. So 3 times y is 3y, 3 times plus 2 is plus 6. 4 times x is plus 4x. And 4 times minus 1 is minus 4. So far we've expanded, we've got rid of the brackets. Now we've got to do the simplifying. The simplifying is when you gather like terms. So you gather up all the x's, where we've only got 4x. We gather up the y's, where we've only got the plus 3y. And we gather up the normal numbers. Now be careful here, this is plus 6, take away 4, which is plus 2. Now part C, when we've got a pair of brackets, the clause work in a different way. We're going to have each of the terms in the first bracket multiplied in turn by each of the terms in the second bracket. Now it doesn't really matter which order you do these in, but I would suggest you start off with the 2t and multiply that by both terms in the second bracket, then move on to the minus 3 and multiply that by both terms in the second bracket. So claw, 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 claw. Now 2t times t is 2t squared. 2t times plus 5 is the plus 10t. Minus 3 times t is the minus 3t. And minus 3 times plus 5 is minus 15. Now the simplifying bit, this is the gathering like terms. So you start off by gathering up the t squareds. Well, we've only got the 2t squared. Then we gather up the normal t's, so that's plus 10t minus 3t, which is plus 7t. And then finally we gather up the normal numbers, in which we've only got the 1 minus 15. Now part D, factorising means popping the brackets in, and fully is giving us a clue that there's going to be more than one component to take outside the bracket. So here we can see we had a couple. So what you have to do, you have to look at each term in turn and take out the highest common factor. So what's the highest common factor of 8 and 12? Well, that's 4. And what's the highest common factor of a squared and a? Well, that is an a. So we can take out a 4a and we open up our brackets. Then we then say to ourselves, 4a times what would give us 8a squared? Well, we need the 2 in order to get the 4 times 2 is 8, and we need another a to get the a times a, which is a squared. So 4a times 2a is 8a squared. Then moving on to the second term, well, it's a plus, so we put the plus sign in. Now 4a times what is going to give us 12a? Well, we need another 3. And then we can just check, because 4a times plus 3 gives us the plus 12a. Question 14. So part A, find in terms of n an expression for the nth term of this sequence. So two components to doing this. The first thing, given it's an arithmetic sequence, we're going to be going up by the same amount being added each time. 11 to 17 we're going up by 6. 17 to 23 we're going up by 6, 23 to 29 we're going up by adding 6. So our first component of the answer is to write down 6n. Had we be going up in 7s, we'd say 7n. Now we need to adjust this. This isn't going to give us the right sequence quite yet, and the easiest way to pick out what this adjustment needs to be is to consider what would be, if you like, the 0th term. What term would come in front of this sequence if somebody was going to push in front of the queue? So we're going down in 6s as we go right to left, going down in 6s. So going down in 6 again from 11, we get plus 5. So our final answer is 6n plus 5. Now, it's quite a mechanical exercise to decide how to work this out, but I think it's really important that pupils appreciate what this does. This allows us to go from a position in the sequence to working out what the actual term is. So for example, this 29, that is 4th in the sequence. That is position number 4, first, second, third, 4th. So position number 4 is when n equals 4. So popping 4 into this expression, 6 4s are 24, add the 5, we do indeed get 29. So what this allows us to do is to work out any term we like without having to just keep on adding 6. So I could tell you straight away that the 100th term in this sequence, which would be when n was 100, was 6 times 100, add 5, which is 605. So it's important to try and get to grips with how this works so you can double check your answer, because it's very easy if you're not thinking to write down 5n plus 6. Now for part B, so this follows on from my explanation of this, is 121 in the sequence? Is there a position in this sequence such that that position generates 121 being in the sequence? So what we go and do, we take our expression and we set it equal to the 121, and then we solve this. So we go and take away 5 from both sides, we divide by 6, and on this occasion we see that n is not a whole number. So therefore we can conclude that 121 is not in the sequence. The 19th term in the sequence would be a little bit below 121. The 20th term in the sequence would be just above it, 121. But all we need to do is show that as n is not a whole number, 121 is therefore not in the sequence. And then to finish, question 15, which is rather a nice question, particularly given it was a calculator paper. So Oliver orders some items from an electrical store. Here is his bill, complete the bill. So we've got the quantity times how much each unit costs, giving us the total. So we can see that 2 times 14.98 gives us 29.96 and so on. So 5 light switches at £6.40 each, 5 times £6.40 gives us the £32. And working backwards, if we're spending £21.96 on light bulbs and they're £1.83 each, £21.96 divided by 1.83 gives us the quantity of light bulbs being 12. And then what's the total cost? Well, we add up these 1, 2, 3, 4 numbers here to get the 88.92. Now for part B, a completely separate part of the question. Some people are muddling these two up in the exam, they're not linked. So Oliver's got £452.25 in his bank account, and during October 3 things happen, so we have to see how this affects his bank account. So Oliver puts £120 into his bank account, so we're going to add that on. He has £2.56 interest added to his bank account, so of course we add that on. And if he's taken £64.83 out of his bank account, of course we have to take that away. So using our calculator, £452.25, add 120, add £2.86, take away £64.83, we get £509.98.